I have included lots of questions from the previous year questions as well as the specimen question papers as well. Hmm? Okay, so we can divide the mole concept into three parts. First, the gas laws, where we are learning about the Gay-Lussac's law of combining volumes. Second one, Avogadro's law. Okay, this is first part. Second part will be the mole concept itself, all things related to mole. Third part we can consider, you know, that stoichiometry also comes with mole concept only. Okay, third part will be your finding the percentage composition, finding the empirical and molecular formula. Okay, so very simple questions will come on the Gay-Lussac's law of combining volumes. First of all, many times they have asked the definition. Okay, so definition you have to make, write perfectly. So when gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the gaseous product, provided that all volumes are measured at the same temperature and pressure. Remember, Gay-Lussac's law of combining volumes is applicable only for gases. Only for gases. You should not use it to find the mass, okay, to find the volume of any solid or liquid. Only for gases. Let me explain this with simple example. See here, you are taking hydrogen gas, reacting it with a chlorine gas, you will get HCl, which is also a gas, and when you balance it, 2. So the Gay-Lussac's law telling us always that when gases react, you are measuring all of the volumes at the same temperature and pressure. T and P means same temperature and pressure. Okay, na? So always the ratio will be simple ratio. So here you see how you find the ratio by the coefficients. So behind hydrogen it is 1, behind chlorine it is 1. So this is one volume. This is also one volume. And to the volume of the gaseous product. So HCl is a gas. Therefore, you can use that as well to volume. So what is the ratio between these three? 1 is to 1 is to 2. Means if I take 1 liter of hydrogen, it requires 1 liter of chlorine to react with. And when they react together, they will form 2 liters of HCl. Volume we are measuring na, so volume can be measured in liter or dm cube. Unit for volume is liter or dm cube, both are same. 1 liter is equal to 1 dm cube. Okay, and if there is a solid or a liquid, say for example I will take another example, right? Methane, burning of methane with oxygen, you will get CO2 plus H2O. Say they have measured the temperature, volume at room temperature and under normal pressure. Okay, now what we know, under room temperature water will be liquid, so you should not apply the Gay-Lussac's law for water. You have to use only the gases. Here methane is a gas, oxygen is a gas, CO2 is a gas, but before you take it you have to balance it. Okay, so carbon 1, hydrogen 4, 2H2, right? Oxygen will be 2 plus 2, 4, so 2O2. Now what will be the ratio for methane? 1 volume for methane, you need 2 volumes of oxygen, and in this process you will get 1 volume of CO2. You should not take water. Now the same question they will change. What they will do, when methane burns with oxygen, it forms carbon dioxide and steam, they mention. Okay, now steam, when you take steam is what? H2O in the gaseous state. Okay, that time you have to use the water as well, or steam as well, you have to find. Same equation, if they mention the temperature above 100 degrees Celsius. And we know above 100 degrees Celsius, water will be in the form of steam. Therefore, that time you can also write 2 volume for the steam. Okay, so it depends upon the temperature. If it is water as a product, it depends upon the temperature. So you have to see the temperature. Under normal temperature and pressure, if they mention, then water, it will be in the liquid state. That time you should not write its volume. Okay. Any doubt in this part? Definition you have to by heart. It will, many times it has been asked. Okay, any doubts? Okay. Let's take this. What kind of questions will come on this? Okay. I try to include different kinds, but all of them are from previous year question paper, so you can see how it is given. Okay. So Aryan, can you read this question? Okay. See what they have asked here. Calculate the composition of the resulting gaseous mixture at room temperature. Correct? So now imagine, you have to understand this question first. This is one reactor. In this, we have ethane, C2H6, and oxygen. Right? So when both of them react, what we get? CO2 and H2O. So everything will be in this container only. Whatever product formed, that is also in this container only, CO2, H2O. But if there is something unreacted oxygen, that also will be remaining in this only. That is also a gas. Since they have asked us composition of the resulting gaseous mixture, means here whatever in this container gases are there, you have to find their volumes. Composition is nothing but volumes you have to find. Yeah. I just explained it now. When you have to find water at room temperature, matlab it will be in the liquid state, so don't find it. If they specifically mention above 100 degrees Celsius or they mention in the reaction as a steam, only that condition. Okay, so that is a tricky thing. They may give such questions in Greenwood High paper, but not in the main paper. Okay. First thing what you have to do, see this is for whole 3 marks and the calculation will be very easy for Gay-Lussac's law. So how to identify where to use Gay-Lussac's law? Everything will be volumes. They will be given only volumes. There will be no mass. You know, the mass in grams, nothing will be given. Only volumes will be given, volumes will be asked. So then you have to use the Gay-Lussac's law. First thing, rewrite the equation and check if it is balanced or not. Then only proceed. Okay. You can solve. But I am explaining it, first listen. Huh? See, because it is for 3 marks, you should not lose 3 marks. Matlab, you have to write something. Na? Calculation is very easy. First thing, you have to write what law you are using. So you have to write according to Gay-Lussac's law. You are using the Gay-Lussac's law. Okay. Now, below the equation, what you have to write? The volumes you have to write. How do you know volumes? The coefficients. The coefficients will give you the volumes. So here for 2 volume, 7 volume, 4 volume, and for water, don't take anything because at room temperature it will be liquid, so you should not find it. Next, what you have to do, you have to find everything which is gas. Now for 60 cc, what is given? 60 cc of ethane, 250 cc of oxygen. First of all, see, 2 volume of ethane requires how many volumes of oxygen? 7 volume of oxygen. Therefore, how much is given? 60 cc. Therefore, 60 cc of ethane requires how much? So, how you know this one? Simple cross multiplication. 2 volume gives you 7 volume or requires 7 volume. 60 cc gives you how much? So, what you have to do? Always cross multiply and equal them. 60 into 70 you have to cross multiply. You equal it to 2 into what you want to find. Okay. So, here it will be 16 to 7. So you are finding oxygen volume now 60 into 7 divided by 2. Okay na? To find how much volume of oxygen you need, you are doing this. Okay, so calculate it. 2 3 210 cc. Unit keep as it is, what they have given. So now see, actually for 60 cc of ethane, you need only 210 cc of oxygen of O2. But actually how much they have given here? 250 cc they have given. In the question, means there should be excess of oxygen which is there in the reactor. Correct? So now we have to find what? Therefore, unreacted oxygen, right? So total is 250. In that, how much is utilized? 210. How much is left? 40 cc. So 40 cc of unused oxygen. Always you do this first. Okay. So that is also there in the reactor. Now come to the product. Second, you also have to write the same way. Now what you want to find in the gaseous product, you have CO2 only. Water we are not finding. Now see the ratio between ethane and CO2. 2 volumes of ethane forms, because it is product now, right? 4 volume of CO2. Therefore, how much we are taking? 60 cc of ethane forms. So what you have to do? Cross multiply. 60 into 4 divided by 2. So 2, 2, 120 cc. Actually, simple calculation. Here only you know. What is the ratio? 2 is to 4. Matlab 1 is to 2. Simply if you do 2 is to 4 ratio, 1 is to 2 it becomes. So if it is 60, you should get 120. Double of that. But you should not do directly. You have to write all these sentences. Okay. So 120 cc of CO2. Now finally you have to write, therefore the resultant gaseous mixture contains how much? 40 cc of unused oxygen and 120 cc of CO2. Okay. So if you write all of this, 3 marks you will get. Okay. Anybody has any doubt in this? See, unreacted part is whenever they have given here the reactants, the values. Here 60 cc of ethane, 250 cc of oxygen. Okay, na? So first of all, you should find 60 cc of ethane requires actually how much oxygen to react. How do you know that? By this equation, 2 volumes of ethane require 7 volume. Means if you take 2 liter of ethane, you need 7 liter of oxygen. But actually how much they have asked here? 60 cc ke liye how much? So how you do? 60 into 7 by 2. Okay. So what you are getting? 210 cc of oxygen. So 60 cc requires only 210 cc. But actually how much oxygen is there in that reactor? 250 cc. Then what about the remaining 40 cc? It is not, it has no ethane to react with. So it will remain unreacted as it is. Only 210 cc will be reacted and remaining will be unreacted oxygen. Okay, na? First, always you have to check whether the oxygen amount is in excess or not. Most of the time it will be excess only. Then a product and all, it is very simple. Rishi, got it? Okay. Any doubt? Okay. But you have to write like this only in the exam. What law you are using? Many of you have told many times, but you don't write what law you're using. Hmm? Don't be lazy in writing answers during the exam. Okay, let's take many more questions. This file will be uploaded. You can check. Chalo, see this question. This is MCQ. 40 cm cube of methane is reacted with 60 cm cube of oxygen. The equation for the reaction is given below. Okay. All volumes are measured at room temperature. So room temperature matlab water is in liquid state. So don't consider water. What is the total volume of the gases remaining at the end of the reaction? See, same question they can give you for 3 marks here. Here also they have asked you to find resultant gaseous mixture, hai na? And here it is only for 1 mark. But still here what you can do, simply you can just check how you are doing it. Anyway, the equation is already balanced, right? CH4 plus 2O2, CO2 plus H2, 2H2. Anybody found the answer? They can tell me. One volume के लिए two volume and one volume and this one is nil. Here all that not necessary because this is MCQ na, straight away we can do. What we have to find? Total volume of the gases remaining at the end. So one volume के लिए two volume. So 40 cm cube of methane के लिए actually how much you need? 60 cm cube of oxygen na? Correct? Double you need na? 40 if you take double of that. 1 if you take 2 you need. 80 you need. But actually how much they have given? 60. So then there will be excess of methane left behind. Right? So you have to do reverse. How much you have taken here? 60 cm cube. 60 cm cube of oxygen के लिए half you need. Means 30 cm cube only will be utilized. So out of 40 cm cube of methane, 30 cm cube is utilized. So what is left? 10 cm cube of methane, which is unreacted. Understood? One volume के लिए two volume ना. So if you are taking for 40 cm cube, one second. If you are taking 40 cm cube, you need 80 cm cube. But actually 80 cm cube is not there. So okay, now we have to calculate it based on the oxygen. So you have 60 cm cube. 2 is to 1, right? So half of that you have to take. So that is 30 cm cube of methane will be utilized. Then remaining 10 cm cube. How we come to know this? 40 minus 30 you have to do. You will get 10 cm cube of methane which is unused. This is first part. Okay. Second part. That is CO2. Water anyway don't calculate. CO2 1 is to 1 is there. Now 30 cm cube we are using matlab this is also 30 cm cube only will form. So now what is the product? 30 cm cube of CO2. Now you add both of them, you will get 40 cm cube total. So total they have asked here is therefore it is 40 cm cube. So similarly in the previous question, do we add that we will write. Okay, so we'll write it individually, then finally we can write total volume. Let's be on a safer side is equal to 160 cc. Yeah, because they're asking resultant gas mixture. Mixture they are asking na. We will write first for whatever individually, then total volume will be 160 cc. We will write like this. Okay. So anybody has doubt in this part? Similar kind of calculation, but in this case, methane is in excess and oxygen is in less. So just for your one more thing, whichever is available in less quantity, that will limit the reaction. That will decide the reaction. So we call such starting material as a limiting reagent. Here in this case, it is oxygen because there is excess of methane. Right, so oxygen is over, reaction will be done, so it is limiting your reaction. So here oxygen is the limiting reagent. In the previous case, oxygen is in excess, but once the ethane is over, that will stop the reaction. So in this case, ethane will be what? Limiting reagent. If they taught you this in school, okay, otherwise just know this one point. Whichever is in excess, that is not a limiting reagent. Whichever is in less quantity, once it is over, the reaction stops. That will be limiting reagent, we call it. Okay, try to solve this, all of you. Ammonia burns in oxygen, equation is already given. Rewrite the equation. 2N2 plus 6H2. What they have asked here, if 240 cc of ammonia is burnt in 300 cc of oxygen, same kind of question. Okay, so what you have to do here, according to Gay-Lussac's law, 4 volume, 3 volume, nitrogen is also gas, right? 2 volume, and what they have asked here, room temperature matlab don't consider water. Now what they have given, 240 cc. So 240 cc के लिए how much oxygen you need? 4 volume of ammonia needs 3 volume of O2. Therefore, 240 cc of ammonia needs 240 into 3 by 4. Right? So 460. 180 cc. Is it correct? 180 cc of oxygen. Right. Therefore, unreacted. Here also you can see oxygen will be 300 minus 180. That is 120 cc. Okay, na? Simple, same question. I mean, similar. Now what you have to find the composition of the resultant gaseous mixture. So nitrogen you have to find. So if it is 4 is to 2 na ratio, then simplify it, 2 is to 1. So it is 240, then half of that, that is 120. So you should get 120 cc of N2, 120 cc of nitrogen. So I have calculated it directly. Now what you will write? Resultant gaseous mixture. Resultant gaseous mixture is equal to unused oxygen or unreacted oxygen is 120 cc and nitrogen 120 cc. So total 240 cc. Gay-Lussac's law calculation part will be very easy compared to other calculations. Okay, anybody has any doubt in this? Okay. Chalo. Okay, all of you solve this one yourself. And once you are done, let me know. Raise your hand. Again, it is room temperature only. Keep that in mind. Keep the unit what they have given. If they have given ml, keep the ml. cc means cc.
Just wait.
Yes, Danish.
शेषाचे रेषे
So what will be the composition final?
So it will be carbon dioxide is 160
Hmm.
and the remaining 20 of the oxygen.
What oxygen? Unreacted oxygen you have to mention.
The other,
Right.
so it's 180.
Right. So 20 ml will be unreacted oxygen and product CO2 will be 160 ml. So total volume will be 180. Anybody having difficulty? Hmm? This is again third similar kind of question. These are all previous year questions only, recently only 2025, 24, 23. From there only have taken. You can see similar pattern. Hmm? So that's why I tell you to solve the previous year questions. Okay, this is one little different kind of question. This I think came from the some specimen paper. Yeah.
So unreacted oxygen is 20.
Yeah, 300 minus 280. Correct, no?
Yes, sir. Yes, sir.
Hmm. Okay. Now see, first you understand this question. Whenever the new type of question comes, don't get, some people will get, afraid of it. Huh? So first read, you will have all of that understanding part. So one variety of household fuel is a mixture of propane, which is 60% and butane 40%. If 20 liters of this mixture is burnt, find the total volume of carbon dioxide added to the atmosphere. The combination reactions can be represented as, actually it is not combination, combustion reaction. Okay, na? What Greenwood High will do, they will not give you these equations. They will give you this question. They expect you to write these two on your own. Okay, so basically what is this? It is a mixture. Say for example LPG at what we have at home. So it is not one single thing, it's actually a mixture of two things. 60% propane C3H8, okay na, butane will be 40% C4H10. Now total volume of this, how much they have taken? 20 liters. Now imagine 60/40 means what? If you take 10 liter of this mixture, in that 6 liter will be propane, 4 liter will be butane. You have taken 20 liter, so propane will be 12 liter, butane will be 8 liter. Correct? Or sir, I want to do the calculation. Matlab, you can simply do percentage. 60% of
So how will you
20.
get 12 and 8?
Percentage. 60% of 20 is what? 12.
Oh, like, okay,
Huh.
okay.
Then remaining 40% of 20 is 8. Okay, na? Or you can simply calculate it. Percentage means always what? 100 liter if you take, 60 liter will be propane, 40 liter will be butane. Right? So same way. Now you know how much propane is there, how much butane is there. Now you need to find what? You need to find the total volume of carbon dioxide. So don't worry about oxygen this time. They have specifically asked only about the carbon dioxide formed when both the reactions are happening. So what you have to do, first write the equations. C3H8 plus 5O2, 3CO2 plus 4H2O. Okay. So now you know this is for the propane. है ना? C3H8 is propane. So propane, how much you are taking? 12 liters. Correct? So by according to Gay-Lussac's law, this is one volume, this is three volume. Now don't worry about the oxygen. So now you need 12 liter के लिए 3 times. So 12 into 3, 36 liter. Simple. Second equation you write 2C4H10 plus 13O2. See, this is difficult to balance if they give you as it is. It will take time for balancing only. 10H2. Now what they have given, okay, according to Gay-Lussac's law, 2 volume ke liye you will get 8 volume of CO2. So now you have 8 liter of uh, butane. So, right, 2 is to 8 means 1 is to 4, correct? 32 liter you will get of CO2. Or you can do the calculation yourself, how you do. 8 into 8 by 2. 8 into 8 divided by 2. Okay. So you will get 32 only. Now, total CO2. You have to finally write total CO2 released will be 36 plus 32. 68 liters. Then it is correct answer, final answer. So this one is for, I think, 3 marks. Okay. Understood. What is the trick here? You don't know what is the volume of propane and butane, but instead of that they have given the percentage here. So from there you have to find what is the value of propane and butane. This is simple mathematical thing. Okay. Anybody has any doubt in this? Clear? Hmm? Okay. One more question. 1250 cc of oxygen was burnt with 300 cc of ethane. Calculate the volume of unused oxygen and the volume of carbon dioxide. So here straight away they have asked you find unused oxygen and volume of CO2. So find it and tell me. Ratio here is there 2 is to 7 for oxygen. So 300 cc के लिए how much? What you have to do? 7 by 2 into 300 for O2. But in the exam, what you have to do? Write the equation, write according to Gay-Lussac's law, right? 2 volume of ethane requires 7 volume of O2. Therefore, 300 cc requires how much? You have to write all of that. Two is to 4 ratio, so 1 is to 2. This is simple. Okay, who have done? Raise your hand. Let's see. Rohani, what you got the answer for unused oxygen?
200 cc.
Unused 200 cc. Okay, used how much?
1050 cc.
1050 cc. Okay, so 1250 minus 1050, 200 cc. Right. So this is 150. Uh, 1050 cc. Okay, and for CO2 should be 600 cc. Okay. So where you people do mistake, when they give you stoichiometry question, you use Gay-Lussac's law. That is the mistake. And when they give you Gay-Lussac's law, use something else. How to identify where to use Gay-Lussac's law? Everything will be given in volumes, and what is asked to find, that is also in volume only. So that you keep in the mind. Hmm.
And usually they don't give atomic masses for games.
Huh. For Gay-Lussac's law, they don't give you atomic masses. That is one more trick. Okay. Why? I could have kept it after that. Chalo. So whatever on the Gay-Lussac's law, I have taken different kind of questions on that. All the previous year questions, including PYQ and specimen. Now let's go to Avogadro's law. Avogadro's law is very simple. In this, no big calculations will be there. If they ask you only for 1 mark, they will ask you to write the definition. Okay. Second one is simply to find number of molecules. So the Avogadro's law or hypothesis. Do not get confused this with Avogadro's number. Okay, Avogadro's number required only for moles calculation and all. Avogadro's law is different. It is only applicable for gases. Okay, so it is a law where equal volumes of all gases under similar conditions of temperature and pressure contain the same number of molecules. Okay, so try to understand. This is very simple. I gave this example many times. Imagine you have three different balloons. Okay, and all of them you have filled with some gas. All of them have volume same, that is 1 liter. Say in the first one I have hydrogen gas. In the second one I have nitrogen gas. In the third one I have oxygen gas. And all the three balloons are at the same temperature and pressure. Okay, so all the three balloons are in your room only. You are not keeping one balloon outside. Like that. If you keep outside, outside it may be more temperature. Like that. So you have to keep all of them at the same temperature and pressure. So what Avogadro's law tells us, when equal volumes of all gases, so all the three gases have equal volume, that is 1 liter, then they will have same number of molecules. Remember, molecules, not atoms. Say I have in 1 liter of hydrogen, I have 10,000, 10k of hydrogen molecules. Then in 1 liter of nitrogen also I will have 10k. In 1 liter of oxygen also I will have 10k of respective molecules. Okay, that's it. If you take, instead of nitrogen, instead of 1 liter, you have taken half liter. Okay, 0.5 liter. Then what happens to number of molecules? That also becomes half. So in 1 liter you have 10k, in half liter you will have 5k. These kind of question only will come. One is definition, another one is this. Okay, let's take, see, this is a question they have asked to define or state Avogadro's law. Statement you have to write correctly. Now imagine there is one gas X, okay, which has 100 cc volume, and another gas Y is there, it has 50 cc volume. Okay, now they have given us that X gas, gas X has some 5,000 molecules. What will be the number of molecules in gas Y? Okay, so Tanisha, can you tell me what will be the number of molecules in gas Y? Tanisha, okay, I'm not able to hear you. Let's try with Dhruva. Dhruva, tell me.
So 5,000 molecules.
In 50 cc?
Oh wait, my bad. So 2,500.
2,500 molecules. Why?
Yeah.
Why? Why 2,500 molecules?
So because it's half of the ICSE,
Right. What law you have used here? What law you used here to calculate it?
the gas, the gas
Gas.
law.
Gas law. Which law? It is given there, na? Huh? Avogadro's law. See, if you know
So the
Avogadro's law.
definition it says like
Hmm.
under similar condition and temperature,
Hmm.
same
Hmm.
number of molecules.
Hmm. But volume is not same,
Yeah,
na?
yeah, yeah, no, I understand.
Hmm. Hmm.
But isn't this Gay-Lussac law?
How? Gay-Lussac's law only for equations. Remember,
Okay.
if there is some reaction is happening. Here, no reaction. Here, nothing related with reactions for Avogadro's law. Avogadro's law will simply compare the number of molecules with the volumes of the gases. That's it.
Yeah,
Okay.
I saw the same number of molecules.
Hmm. Same number of molecules when you take equal volumes. Or remember, same volume, same number of molecules. Okay, that will work. Same volume, same number of molecules. Hmm? So only these two kind of questions will be asked on Avogadro's law. One is statement, another one is whatever I have given here. But Greenwood High, what they will do? They will twist the question. Hmm. So they have taken hydrogen gas, oxygen gas. Hydrogen gas they have taken 100 cc. Okay, oxygen they have taken 100 cc. And one more gas, helium. Helium also they have taken 100 cc. Now they will ask you what is the ratio of number of atoms. Ratio of number of atoms between these three. Okay. Now what you people do? Ah, sir, same volume is there. So same number of molecules will be there. So 1 is to 1 is to 1 you will write. Correct? But they have asked the number of atoms, not the molecules. So that is a twist. Now, sir, what to do? Simple. Hydrogen has how many atoms? 2. Oxygen has how many atoms? 2. But helium will exist as atom only. 1. So the ratio will be 2 is to 2 is to 1. Hydrogen is to oxygen is to helium. If the ratio between the number of molecules they ask you, it is same 1, 1, 1. That will not change. But every hydrogen molecule has two atoms. So if they ask you the ratio of number of atoms, it is 2 is to 2 is to 1 because helium exists as atom. Okay. So this has been asked previously also. Therefore, I am telling you this. Clear na? So be careful. Therefore, you have to read the question carefully whether they have asked the number of molecules or number of atoms. Chalo. So in Avogadro's law, only these two things, nothing else. Let's go to some basics before we go to the mole concept. These definitions they will not ask you, relative atomic mass and all they will not ask you, but you should know what is it. Hmm? Relative atomic mass we usually what we express it in AMU values, or simply you can also mention it in U unit. Hmm? And relative molecular mass, when you add the atomic masses you will get the molecular mass, that you already know. The unit for that is also AMU or U. But this one, gram atomic mass. Gram atomic mass is what? Whatever the atomic mass is given, you write it in grams. That will be gram atomic mass for that particular atom. Because atoms have atomic mass, molecules have molecular mass. So see, oxygen atom is there. Its atomic mass is 16 AMU. But if you take 16 gram, that will be its gram atomic mass. Okay, this is very important. And that will be it's called as 1 gram atom. So what is 1 gram atom? It is equal to the gram atomic mass of that particular atom. So here oxygen ka gram atomic mass is 16 gram. So 16 gram of oxygen is 1 gram atom of oxygen. Now they ask you what is 2 gram atom of oxygen. To multiply it by 2, right? 16 into 2, 32 gram of oxygen atom. That will be 2 gram atoms. So whenever atom comes here, you have to take the atomic mass. If
Sure.
molecule comes, you have to take the molecular mass. Yes.
So 1 RAM is equal to 1 gram atom basically.
Huh. Not actually equal, numerically equal. Numerically 16, 16, but unit wise they will change. Alright?
So if they ask 2 RAM of oxygen is 32, for example, so
2
it's 2
RAM,
gram atom.
2 rem they will not ask you. Okay, either they will ask you 1 gram atom, okay, or what is gram atomic mass.
So like I think RM function is 16 AMU is constant and then gram atom will ask like changing.
Huh. Because this will change. Atomic mass will be fixed, but your gram atomic mass keeps on changing. And this we are going to relate it with the mole. Therefore, it is important. Hmm? Similarly, gram molecular mass is what? You know how to find the molecular mass. Say I have asked you to find molecular mass of water. So you will find 2 plus 16 is equal to 18. So 18 AMU is the molecular mass of water. See, molecular mass, relative molecular mass, molecular weight, all are same. And if they ask you what is the gram molecular mass of water, you just express this in the grams. That is 18 grams. What is changing here? Only the unit is changing. That's it. Numerically calculation, everything is same, but the unit you have to change into grams. Okay. So here you have to take molecular mass if it is a molecule. You have to take atomic mass if it is an atom. So here you see relative molecular mass of oxygen molecule. Oxygen molecule is O2. It is 32 AMU. And you
So it's
express it in
16 plus 16.
grams. 32 grams. Hmm?
So in the exam can they ask gram atom mass also? How
Gram?
many molecular mass? In the exam can they test us about gram atom mass also?
Gram atomic mass they can ask you. Or simply gram atom they will ask you. Mostly not gram atomic mass. What do you mean by 1 gram atom? Or find the number of gram atoms. Okay. Or number of gram molecule. All of them have same formula, I will tell you. Hmm? Okay. Okay. So Iona, tell me what is, you have to name this. What is this? Or give the term.
Is it hydrogen?
No, the amount of substance which contains the same number of units as the number of atoms in carbon 12.
I'm not sure.
Rushi,
Okay, I forgot about this one.
why are you raising your hand? Aryan,
So one mole.
one more.
Oh,
So this is the definition of the mole. Okay. If they ask the definition of the mole, this is the one. The amount of substance which contains the same number of units as the number of atoms in carbon 12. But for calculation and all, I will make it easy for you. Definition, if they ask you, you have to write this one only. There is no option. But calculation part, I will make it easy for you. So this is the definition which I just explained you. But what is actually the mole means? So I will compare it with dozen. See, then it will become easy for you. 1 dozen, all of us know 1 dozen means 12. Correct? Huh? So if I ask 1 dozen of X, 12 X. 1 dozen of banana, 12 banana. 1 dozen of pens, 12 pens. Similarly, numerically, 1 mole has a value. It is a collection of 6.023 into 10 to the power of 23 items. Okay, just like dozen. You can use it for anything. 1 mole of eggs, if I ask, how many eggs? 6.023 into 10 to the power of 23 eggs. Actually, how those many eggs will not be there in any shop, right? 1 mole of pen, if I ask, 6.023 into 10 to the power of 23 numbers of pens. Okay. Therefore, 1 mole is always a collection of these many number of things. Yes.
so is it 6.023 that number? Isn't it number of molecules and not the number of like quantity
Why only number of molecules? That's what I'm telling you here.
or atoms basically?
Basically, that
Particles.
no, this number is so huge that we don't use it in our day-to-day life. We use it mainly for chemistry calculation purposes, because in particles, number of particles, they are huge in numbers. Why? But in understanding part, you have to understand that it is just a collection of 6.023 into 10 to the power of 23 number of items. It may be anything. Okay, first you keep that in mind. And this number we represent by this notation Na. We call it as Avogadro's number. Avogadro's number. Do not get confused this with Avogadro's law. Avogadro's law is only for gases. Okay? So that first part what we learned, Gay-Lussac's law, Avogadro's law, that is done. This what we are learning now, it is the second part, mole concept. Instead of every time I am taking this one, I will now onwards take Na. So it is understood that Na is nothing but 6.023 into 10 to the power of 23. Now if I take, since this is so huge, we don't use it in our regular day-to-day life. We use it mainly to calculate the number of particles. So here particles means what? They may be atoms, number of atoms, or they may be molecules, or they may be number of ions, number of electrons, number of protons, number of neutrons, any small particles. Okay. Now, if I ask you what is 1 mole of atoms, Ruhani, tell me 1 mole of atoms is what? How much numerically?
Sir, it will be 6.023 into 10 raised to power 23
What? Atoms.
atom.
Right? Okay. Chanvi, 1 mole of molecules means?
So 6.023 into the 10 to the power 23 molecules.
Very good. Darshwana, 1 mole of ions.
So 6.023 into 10 to the power 23 ions.
Right. Danish, tell me 1 mole of eggs. Danish?
Yes, sir.
Hmm.
6 was very 6.023 into 10 power 23 eggs.
Yes. Okay. So it is just like dozen. You can use it, but this is so huge that we don't use it in our day-to-day life. Okay. So first of all, 1 mole with the number of atoms or molecules, whatever the numbers you are connecting here, first you make note of it. 1 mole with respect to number is always 6.023 into 10 to the power of 23 with respect to numbers, which I can just write any. Okay. Now another
So we
relationship.
don't use moles that often. Why is it a standard unit?
It's not an unit. It's just a number. Dozen. Why you use dozen? To make your work easy, na? 1 dozen.
Yeah.
Same way in chemistry, 1 mole we use it to make our work easy. There are lots of things behind it. Why only this number and all, but that we are not going to learn now. Okay. Okay. Instead of explaining you slides, I will explain here. So first relation what we got between the moles and number of particles. This is one. Second relationship we are going to get here is 1 mole. Okay, so we'll write here mole and mass. The relationship between mole and mass. So if I take 1 mole of an atom, okay, what will be the mass? Now number you know, 6.023 into 10 to the power of 23 atoms. But what will be the mass of that? That will always be equal to the gram atomic mass. Now what is your gram atomic mass? Whatever atomic mass you have given, you just express it in grams. Say they will give you carbon's atomic mass is 12. Now they ask you what is the mass of 1 mole of carbon. Okay, so 12 is there, so keep it grams. That's it. 1 mole of carbon is 12 grams. Okay, hydrogen atomic mass is 1. So what is 1 mole of hydrogen? I'm talking only about the atom, don't take the gas. Hydrogen atom, it is 1 gram. 1 mole of oxygen atom, atomic mass of oxygen is 16, so 16 grams. 1 mole of nitrogen atom, 14 grams. Okay, so this is the 1 mole of an atom is always equal to the gram atomic mass of that particular atom. Clear? Anybody has doubt in this? Chalo.
Oh, sir.
Now, if instead of atom they give you molecule, what you will do? You will equate it to whatever molecular mass, but in grams. Okay, na? 1 mole of molecule will be how much mass? It will be the gram molecular mass. Gram molecular mass. In this case, you have to take the molecule. है ना? So if I take now 1 mole of hydrogen gas. Now hydrogen is what? In the gaseous form, it's a molecule. So find the molecular mass of hydrogen, 2. Right? So 2 grams. Now don't keep 1. If it is atom, then 1. If it is a molecule, then you have to find the molecular mass. 1 mole of water. Okay. Isha, can you tell me 1 mole of water means how many grams? Molecular mass of water you find? Hydrogen ka 1, oxygen ka 16.
It's 18 grams.
Correct. That's it. 18 grams. Okay. 1 mole of NH3. Vanishika, tell me. Nitrogen ka atomic mass is 14, hydrogen ka 1.
17.
Unit?
17.03.
17?
17 grams.
17 grams. That's it. Okay. ठीक है. Now what I will do, I will connect the first part also. What is that? Number of particles, right? So now 1 mole of hydrogen gas weighs how much? 2 gram. And what will be the number of molecules in that? 6.023 into 10 to the power of 23 hydrogen molecules.
So 1 mole of any molecule is equal to its gram molecular mass.
Yes. 6.023 into 10 to the power of 23 water molecules. This one also what? 6.023 into 10 to the power of 23 ammonia molecules. ठीक है? Simple. Now I connected the first part also. So can we write 1 mole of H2O equal to 18 grams of 18 grams will be the mass. Okay. In that, how many number of water molecules are there? 6.023 into 10 to the power of 23 molecules are there. Now, what I am giving you relationship, mole, 1 mole means how many grams? 1 mole means how many number of particles. ठीक है ना? And now they may give you mass and ask you number of particles. Now we also know the relationship between these two. Correct?
So,
Hmm.
so if they say number of atoms in H2O molecule,
That I will come.
how are we going to see it?
Now see what they will change the question. They will take 1 mole of water and they will ask you what is the number of atoms, not the molecules. Now you know water is a molecule, but they are asking you what is the number of atoms in 1 mole of water. Okay, don't get confused. Very simple. 1 mole of water, numerically you know how many molecules of water. That will be 6.023 into 10 to the power of 23 molecules. Correct? Huh? Now what do you do? Just keep it as n number of molecules or na number of molecules. Now in one water molecule, how many atoms are there? One
One.
water molecule.
Three atoms.
In H2O, total number of atoms will be, there are two hydrogen and one oxygen. Total number of atoms in one molecule of water.
Three.
Right. Now you have n number of molecules. What you will
So
do?
three into that 6.03.
Yes. So that's it. What you have to do now to find the number of atoms. So you have to multiply. In one molecule you have three atoms. So in n number of molecules you will have 3 Na. Na is what? 3 into 6.023 into 10 to the power of 23 atoms now. Okay. Therefore, it is very important to read the question what is asked. Don't straight away write 6.023 into 10 to the power of 23 atoms. No. If it is a molecule, actually it is a molecule. Then you have to see in one molecule how much is it. Otherwise, always simple way is whatever H2 is there, total 3 is there now. So number of atoms will be 3 Na. NH3 is there. Okay. Total number of atoms will be 4. So number of in 1 mole of NH3 if you take 4 Na. In that also they may ask you what will be the number of hydrogen atoms or what will be the number of nitrogen atoms. Say for example, I will change this. Uh, Number of hydrogen atoms in 1 mole of water. Okay. Now what you to do simple way is whenever you take any compound 1 mole, you just take the number of atoms as it is. See, in hydrogen what is the coefficient? 2. So in one water molecule you have 2 hydrogen atoms. So in 1 mole of water you will always have 2 moles of hydrogen atoms. Okay, and oxygen atom is 1, so 1 mole of oxygen atoms. So straight away you can find it. Number of hydrogen atoms will be 2 moles. 2 moles means what? 2 into 6.023. Moles is 6.023 into 10 to the power of 23. So just keep as it is. And what will be the number of atoms in 1 mole of water? 1 mole of oxygen atoms. That is 1 into 6.023 into 10 to the power of 23 oxygen atoms. What they may change? If I take 2 moles of water, what will be the number of atoms of hydrogen? So 2 into 2, 4 moles. You know 4 moles of hydrogen atom, how to find? Now 2 into 1, oxygen will be 2 moles of oxygen atom. 4 moles of hydrogen atom, 2 moles of oxygen atom multiplied by Na. That will give you the number of atoms. Okay. This, if it is very difficult question paper, they will give you this. Otherwise, regular previous year questions I will show you. They will be very simple, straightforward questions. ठीक है ना? So first of all, you should know. Now you know mole and mass, mole and number of particles. One more relationship is there, which is applicable only for gases. For gases, what is that? 1 mole of any gas occupies 22.4 liter at ST. Okay, this is only for gases, huh? Don't apply this for solid or liquid. Now you know the relationship between 1 mole of a gas with its volume. So 1 mole of gas is 22.4 liter at standard temperature and pressure. Instead of sometimes giving you standard temperature and pressure, they may give you temperature and pressure 1 atm, okay, 0 degree Celsius or 273 Kelvin. So then you should understand it is standard temperature and pressure only. Okay, now you know one more relationship, that is 1 mole of a gas will occupy 22.4 liter at STP. Now I will take 1 mole of NH3 gas. Okay. Now previously we have seen how to find the mass of this, whatever molecular mass is there, express it in grams. So it will be 17 grams. And how much volume it will occupy? 22.4 liter at STP. And what will be the number of molecules in 1 mole? 6.023 into 10 to the power of 23 ammonia molecules. Okay. Now you have all the relationships required for calculation part. If you know these three things, they will just change the questions. That's it. Okay. But basic relationship, you should know this is the one. Let's take some questions. Hmm. What will be the mass of carbon dioxide that will contain the same number of molecules as present in 3.2 gram of oxygen gas? Very, very confusing, right? They are asking us, you have to find the mass of CO2, which will contain the same number of molecules as present in 3.2 gram of oxygen gas. Right? So how do we know how many number of molecules are there in 3.2 gram of oxygen gas? You know, we don't know that. But we know 1 mole always have the same number of molecules, whatever substance it is. Correct? So what you have to do first, you have to find what what will be the number of moles for 3.2 gram of oxygen gas. So simple formula, you remember, you have to use it everywhere. Mole is always calculated by mass divided by molecular mass if it is a molecule. Okay. Or if it is an atom, sometimes say sodium, if they give you, it is an atom, right? So you have to divide it by the atomic mass, mass divided by atomic mass. Now same relationship you will use it to find the gram atom also. If they ask you number of gram atoms, then use the same formula, mass by atomic mass. Gram molecule, mass by molecular mass. Always. These two are very important formulas. Okay. Now, 3.2 gram of oxygen gas may, what will be the number of moles? So, number of moles is equal to mass, how much they have given? 3.2 gram divided by. What will be the molecular mass of oxygen gas? So that you can find from here, O2. O2 may 16 into 2, 32. So divided by 32. So what will be the answer for this? 0.1, huh? Correct? 0.1 mole. Now, how many number of atoms are there in 0.1 mole? Right? Same number of atoms or molecules will be there for carbon dioxide if carbon dioxide is also zero point 0.1 mole. Because we know 1 mole always have the 6.023. Correct? So if you take 1 mole of oxygen, same number of molecules will be there in 1 mole of carbon dioxide. But actually oxygen is how much here? 0 0.1 mole. Then you have to take 0 0.1 mole of CO2, that also contains the same number of molecules.
So if to equate both of the,
Hmm?
if to equate them, right? 0.1 was to carbon dioxide.
Huh. Now you
You have to
find
find the
molar molar volume. Rohani?
dioxide and the mass.
Tanisha, can you repeat your question?
Do we have to find the molar mass of carbon dioxide?
Yes, we have to.
And then we have to multiply it with oxygen,
Yes,
right?
yes. Now then you have to multiply with the number of moles of oxygen whatever you found. Okay, now. So here same formula you can use here. Now you don't know the mass of the, you want to find the mass of the carbon dioxide. So formula, same formula you use. Now mass will be what? Mole into molecular mass. Correct? Now mole, how much you have to take? 0 0.1 mole only, because same number of moles will have same number of molecules. So 0.1 into molecular mass of CO2 you have to find first. CO2 के लिए 12 plus 32 44. So 0.1 into 44 is equal to 4.4 gram. Okay, see, it may look big, very big, but if you understood the concept and keep on practicing more questions, it will become very easy. 0.1 mole of CO, carbon dioxide, ठीक है, carbon dioxide का molecular mass is 44, so divided by 10, so 4.4, that will give you 0.1 mole, right? So that will be the answer. So what will be the mass of CO2? 4.4 gram. In the exam you have to show the calculation. See, 2 marks. Some people directly write the answer. Don't do that. Even if your answer is correct,
So
you
how
will.
can you directly write the answer?
Some people do that. I don't know. Okay, they will do everything in the mind and then write it. Hmm? So don't do that. Show the calculation always. Anybody has any doubt in this? Hmm? So what is here? You should know always number of moles. If they are equal, then the number of molecules also will be equal for any substance. Okay. Here only we can also take the stoichiometry questions as well. So this is a stoichiometry question. Before this, I skipped one question, that is this. Hmm. First we'll take this. Which of the following would occupy 22.4 liters at STP? So what you should know, always it should be 1 mole. है ना? Okay, how many of you know the answer? Only one. See, first of all, find the number of moles. Okay, whichever is 1 mole, that will occupy 22.4 liters. That's it. Now, Chanvi, tell me, 32 grams of oxygen means how many moles?
Sir, 2 into 6.023. That's
Moles. You are finding the number of particles. Moles. Hmm.
So one.
1 mole, correct?
Yes.
Hmm. And this is anyway straight away given 2 moles. Correct. Third one. Third one, this will be how much mole?
1 mole.
1 mole only, because 1 mole will have these many number, right?
Yeah.
Now, see, second one is incorrect. Wherever second one is there, cancel out that. This one, this one, this one. What is left? 1 and 3.
1 and 3.
That's it. Okay. Instead of calculating all of this, I explained it so that you can understand, all of you. If you first only you see 2 moles, then straight away remove the second option. Then what is left? 1 and 3. So that will be your answer. Even no need to check the first and third. You know? So these kind of simple questions will be there only if you understood the concept. Otherwise, everything will be very difficult. So for that, what you have to do, you have to solve a lot of questions, different kinds of questions. Okay, now let's take this stoichiometry question. How do we know it is a stoichiometry question? One equation will be given, usually 2 or 3 sub questions will be given. Okay, na? And here do not use the Gay-Lussac's law. Whenever,
Is this that chemical reaction question?
that is a stoichiometry question. Hmm.
Oh.
Stoichiometry is not something else. This is the one. Okay, where you are finding the relationships using your mole concept knowledge to solve the or find out something. Okay, so this question actually is very simple. Here there is no big calculation. I think I have given you this in the exam as well. Okay, so first of all you have to rewrite the equation. First thing, you always do that and check whether it is balanced. As I told you, in the board paper it is always balanced, but in your Greenwood High paper they may not be, they may not give you balanced equation. So you have to check that first. Now come to the question, what is the mass of 5 moles of calcium carbonate? Here they made your work easy. They have not given any atomic masses. They already gave you relative molecular mass of calcium carbonate is 100. So you know that 1 mole is,
M is equal to
no, no,
mass they give by the
no need to do that. You know 1 mole is equal to 100 gram, because 1 mole is equal to gram molecular mass. They have already given you the molecular mass, so express it in grams. So 1 mole is 100 gram. Therefore, 5 moles will be 500 grams.
500.
That's it.
So, but the formula is also is not wrong, right?
Which one?
N is equal to the mass being used by
Why you want to
the
do that?
molecule.
Here you are simple way na doing it. Why you want to make it complicated? One step only. You got the answer. Huh? Huh. Uh, we'll see such questions also where you have to use remaining things. Second one, see. How many moles of HCl will react with 5 moles? Now, how do we know this? Simple. Ratio you have to see. Don't take volume now. You have to take moles. Huh? So here coefficient for calcium carbonate is 1. So it is 1 mole. For 1 mole of calcium carbonate, how many moles of HCl is used? 2 moles. तो 5 moles के लिए 10 moles. Correct? 1 mole CaCO3 needs 2 moles HCl. Therefore, 5 moles CaCO3 needs 5 into 2, 10 moles. Simple. Okay? No need to make it complicated.
So if they ask how many grams of HCl will react with 5 moles?
Then you found 10 moles now. Correct?
Yeah.
So 1 mole of HCl is how many grams?
Uh,
Its molecular mass. है ना?
30. Yeah, so what's the
36.5 gram.
yeah, okay.
So 10 mole will be 365 grams. One second. No, moles to moles you find. Then you know 1 mole is equal to how much. Then you do the mass also.
Okay. So we
Always
can do it
come to
directly.
moles. Come to moles, then you connect it with other things. That will become very easy.
Okay.
Hmm.
So I
Okay.
have a question.
Yes.
So why can't we like this? Like you know the related molecular mass of calcium is 100 and your guess 5 moles is 500 grams.
Hmm.
So you can like put HCl also as 66 and X. So you
Hmm.
can do cross multiplication, right?
That calculation you want to waste the time? Or this one is simple. Straight away it is there, na? Isn't it? 1 mole, 2 mole requires, and they have asked you the number of moles. Why you want to take the grams and all? Huh? So directly, okay, 1 mole के लिए 2 mole you need. So 5 mole के लिए 10 moles. I will give you such questions also where you have to use mass also. Otherwise, always use moles to mole ratio, then connect it with the mass. That will be very easy. But that also can be done. But there is a chance
So
that you will do a miscalculation. Okay, that one possibility is there.
so can you show the step for that? Like how
That
you
I
can
will
cross
take
multiply?
next question, not for this. Okay, na? Now, what is the volume of carbon dioxide liberated at STP at the same time? Now, see, carbon dioxide is here. Same time, matlab what? When you are taking 5 moles, that you have to understand. Okay. Now, ratio between calcium carbonate and CO2 moles. What is it? 1 mole CaCO3 will give you how much? 1 mole CaCO2. Correct? Actually, how much moles you are taking? 5 moles. 5 moles CaCO3 will give you how many moles? 5 moles of CO2. But they have asked you volume. You know now 1 mole of any gas occupies 22.4 liter at STP. Correct? So here 5 moles के लिए 5 into 22.4 liter. If you do 112 liter of CO2. This is the simplest question they can ask you on stoichiometry. Okay, where the calculation is so simple. Okay, I will show you the difficult also. Hmm. Okay, define the following molar volume. Molar volume is nothing but that 1 mole of any gas occupies
Mass
22
occupied
point,
by
no wait, 22.4 liter at STP. This is the definition of molar volume. Okay, here I just want to give you one more thing. 1 liter is equal to 1000 ml. Okay, these units also you should know. 1 dm cube is equal to 1000 cm cube, and always 1 liter is equal to 1 dm cube. Therefore, you can also interchange ml and cm cube also. Okay, because sometimes they change the units, but whatever units they have used, you use that one only. Therefore, 22.4 liter means 22,400 ml. Okay, if they give you 22.4 dm cube and something in cc they have given, then 22,400 cc. These simple conversions you should know. Okay na? Take this question. 1 mole of CO2 occupies 24 dm cube at room temperature. See here, dm cube they have given. Calculate the following. 1 mole of CO2. How much it is? 24 dm cube. The mass of 6 liters of CO2. Okay. Now what we know, 1 mole of CO2 is, they see here don't use 22.4 liter because they have given you value. So use that value. So 1 mole of CO2 is 24 dm cube. Now you know 1 mole of CO2 weighs how much? Its molecular mass. Correct? Which we have found previously na 44 grams CO2. 12 plus 32 is equal to 44. So 1 mole of CO2 is equal to 44 gram, which is occupying how much? 22 dm cube. So 6 liter, 6 liter and dm cube we can interchange as I just told you. Okay na? So if you are taking 22 liter, what is the mass of that? 44 gram. 6 liter ka will be how much? Okay. So multiply it. 44 into 6 divided by 24. No, sorry. 24. 24. So do this calculation. 11. So 6 liter of CO2 will weigh 11 grams. Did you understand how I used it? I taken 1 mole is how many grams. Then I connected it with the value they have given with in the volumes. So I know now 24 liters matlab 44 gram because 44 gram is 1 mole of CO2. Therefore, 6 liter will be how many grams? So 11 grams. Okay, 1/4 basically. Anybody didn't understand this?
So the second part,
Second part I didn't do only. Second part means B.
so no, sir, of this part only, the 24 liter to 44.
Array, okay, see. Okay, this is 24 now. Now you know 1 mole is 44 gram. What is the volume of 44 gram here? They have given?
22.4.
No, they have given 24 now.
Okay.
Have they given STP? No, na. They have given value 24 dm cube at room temperature and pressure. So you
Okay.
have to use that. So 24 liter is weighing how much? 44 gram. Therefore, 6 liter will weigh how much? Simple
Okay.
calculation.
Fine, sir.
Hmm. It will be 11. Sorry, that was my mistake. Okay, na? Second part. This is A. Second part. The volume occupied by 60 gram of CO2. Okay, now you should find what is the value of 60 gram. Means how many moles of 60 gram. One way is you can take directly gram to gram. That is 44 gram occupies, they have given 24 dm cube. Therefore, 60 gram occupies how much? This is one way. Or you can find the moles. 60 gram means how many moles? Okay. But this will be better here because they have already given for 60 gram. So what do you do? 24 into 60 divided by 44. Okay. So do this calculation. Tell me how much value you are getting here. How much?
So 32.7 approximately.
30?
2.7.
32.7.
Yes.
Uh,
Yes, 32.7.
okay.
Like I only dictated the first estimate.
Okay. 32.7 dm cube. This is one way, or another way, mole to mole you can take. Okay. So now 1 mole is occupying 24 dm cube. So 60 gram means how many moles? So how you will find moles? Mole is equal to mass divided by molecular mass. So 60 divided by 44. Okay. It's nothing but same only. Here you can see 60 by 44 it is here now. That you are finding here separately. Okay. Whatever value comes that you multiply with 24, that you will get the final answer. Okay. Chalo. See, if you're not understanding, please don't sit quiet. So this is the last chance you have to you know, get on this and understand and solve many questions. Okay.
Sir, that question only I didn't understand how to do. The second part.
Second part you didn't understand. Huh?
Mm,
What is
yes.
the difficulty here?
Sir, this part calculation. What did you do?
How did I do? Okay. Now I did in the first part what 44 gram. No? You know how the 44 gram came here?
Yes.
How?
And this thing, 1 mole of CO2.
Okay. So I know 44 gram means how many, what is the value of volume? 24. They have given it. है ना?
Ah.
Okay. And they have asked 60 gram के लिए how much? Simple calculation ना?
Mm-hmm.
44 के लिए 24, 60 के लिए how much? So what you have to do always cross multiply 60 into 20, 24 divided by 44. So solve this, you will get the answer. Okay, this is
Ah.
very, see in mole concept you don't have any big difficulties. If you know the relationships, then it is very simple. Only calculation error you may do. Otherwise, it should not be difficult. Okay, see here. Which of the following will occupy the volume 2.8 liters at STP? Now, see, STP they have given, and 2.8 liters at STP. So, matlab, 1 mole will occupy 22.4 liter at STP, correct? So, 2.8 liters, matlab, it should be less than 1 mole, correct? Huh? Or you can find it. If it is less than 1 mole, and if it is near to that 2.8 liter means it must be 0.1 and something should be there. If it is 0.1 mole you should get 2.24 liter, but it is actually 2.8 liter, so it should be 0.1 something. So 2 moles, no. 7.1 gram of chlorine. Chlorine is a gas, है ना? So Cl2, what is the molecular mass? 35.5 into 2, 71 gram. 7.1 gram is how many moles? 7.1 divided by 71 is 0.1 mole. 0.1 mole means it should be 2.24 liter. So this is also not correct. है ना? 8 gram of sulfur dioxide. Sulfur dioxide you find 32 plus 32, 64. 8 by 64. Right? Moles I am finding. Uh, 1 by 8. 1 by 8 will be how much? 0.1. Okay. 2. Correct? 0.12. So I think this might be the answer. But let's see last one also. 56 gram of carbon monoxide. Carbon monoxide is 12 plus 16. You know? So 28. So 56 matlab it is to more than 1 mole. So this is also not correct. So it should be 8 gram of sulfur dioxide. Okay. Hmm. This one I think I gave in the exam. Okay. Darshwana, tell me how many moles are present in 10 gram of CaCO3?
Yes. 1 minute.
Hmm. You have to use the formula.
Yeah, so I was calculating the mass 52
Right.
plus 16 into 3.
Hmm. 100, no?
Yeah,
Hmm. Mass is 10, molecular mass is 100, correct?
0.1.
Hmm.
Yes, sir.
Okay. Chalo. Sometimes you can also remember like calcium carbonate straight away the molecular mass 100. Usually whichever questions repeated. Okay. Or sulfuric acid. I remember sulfuric acid is 98. Sodium hydroxide I remember 40. Carbon dioxide 44. Otherwise you can calculate, not a problem. The ratio between the volumes occupied by 22 grams of carbon dioxide, 10 gram of hydrogen gas. Very, very, see, question, volumes, the ratio they have asked. 22 gram CO2 is to 10 gram hydrogen. So what you have to do whenever they give you ratio between volumes, ratio between number of molecules, ratio between number of atoms, always take the moles. So
So
if
it's
the
like
number of moles is same, then they have same number of things, same volume, same number of molecules, like that. Hmm? Yes.
so can you first simplify the ratio so it's easy for calculation?
Huh?
Can you first simplify the ratio divided by 5?
That okay, you can find the number of moles and find it. Divided by 5 you are doing the.
No, like the ratio is like a big number. Can you like simplify it?
How you will simplify?
It becomes 11.5, right? You can divide by 2.
11.5 divided by 2.
So, but you can't do that.
Hmm. You have to find the moles. Mass is given whenever moles you find. है ना? See here 22 CO2 I just told you 44 gram is the molecular mass. So 22 by 44. 1 by 2 is 0.5. Hmm. This one 10 gram hydrogen ka molecular mass is 2. So 10 by 2 is 5 moles. So the ratio between CO2 and hydrogen moles is 0.5 to 5 means 1 is to 10. If you simplify this 1 is to 10. So volume also will be same 1 is to 10 because 1 mole 10 mole. At STP this will be 22.4 liter. It is 10 into 22.4 liter like that. Okay. Always, as I told you, find the mole, whatever ratio between the mole, that will be the ratio between the volumes, ratio between the number of molecules also. So don't keep on doing again next part. 1 mole is 22.4 liter. That part is not necessary. Moles, if you come to know, same ratio will be there. Okay, this one. Ruhani, tell me.
Yes, sir. C 44.80.
1 mole is 22.4, 2 moles is double. Okay. See here. The atomic masses of sulfur, oxygen, helium are approximately 32, 16, 4. Okay. Which of the following statements regarding the number of atoms in 32 gram of sulfur, 16 gram of oxygen, 4 gram of helium is correct? Okay. So here they have not given oxygen gas. So don't take oxygen gas. Okay. Whatever oxygen given means atom they have given, not the molecule. Only if they mention gas, then it is a molecule. Now very simple again what they have asked here. Which of the following statements regarding the number of atoms? So two statements are given. So which statement will be correct? They have asked. So first of all, see all will be how many moles? Find the moles first. 32 gram means 1 mole because it is atomic mass. 16 gram is also 1 mole. 4 gram is also 1 mole. Okay, na? Now you can tell the answer. Yes, Danish, what is the answer?
So both are wrong.
Okay. Rishi, what is your answer?
Yeah, so both are wrong.
Hmm. So because 16 gram of oxygen contains 4 times the number of atoms. See, number of moles are same, matlab some number of atoms also will be same. So all should have same number of atoms. So here again, second part you see half the number of atoms. Matlab this is also wrong. So neither P nor Q. Both are wrong. Okay. This is how we have to solve these questions. The ratio between the volumes occupied by 4.4 grams of carbon dioxide and 2 grams. Similar kind of question previously what we did. Ayuna, tell me what is the answer for this?
So 44 grams of carbon dioxide, so it's going to be 0.1 mole
Hmm,
of
correct.
carbon dioxide,
Hmm.
and then 2 grams of oxygen is normal one mole only.
Hmm. So the ratio will be
1 is to 10.
huh. Okay, same. So again now we found the number of ratio between the moles. So same thing. You simplify it, multiply by 10. So here 1, here 10. Which of the following could weigh the least? Again, what you have to do here, don't keep on finding the mass of everything. Just find the moles. Whichever has lowest moles, that will be the least mass. Sorry. Here mass के लिए you can't do that. Sorry. Mass के लिए you can't do that. Moles because different things have different masses. So mass के लिए you can't do that. You have to find the mass here. Okay. 2 gram atoms of oxygen. See, gram atom is nothing but moles only. Remember, gram atom is moles. Gram molecule is also moles only. So
So
2
2 moles.
moles. हाँ, 2 moles matlab 16 into 2, 32 grams. 1 mole of sodium. Sodium is atomic mass 23, so 23 grams. 22.4 liters of CO2. This is nothing but 1 mole only. But 1 mole of CO2 is 44 grams. We just know that. This is also 1 mole. 1 mole of carbon here is 12 grams.
12.
So the least will be D.
Carbon.
Yes. And they may change the question, which one would weigh the most? Then it will be C part. Okay. So you have to read the question again. What they have asked, least or most.
So always the molecule will be more than the element, right?
Huh, but there is a bigger element means like 118 elements are there. Something which is more than 44 element can have the atomic mass more, no? Like silver. Silver is 108. So that is very huge. Hmm? Chalo. The ratio of the mass of a certain volume. You have to name this. Aryan, tell me the answer. Certain volume of the gas to the same volume of hydrogen measured under the same conditions of temperature and pressure. Very good. This is called as vapor density. So whatever mole related questions are there, we are done with that. The last part we are going to do is vapor density, finding the empirical and molecular formulas. Okay. But this may not be end at 12 o'clock. We may need to extend it. Okay. We'll take 3 minutes. So now we are going to the third part of mole concept, that is vapor density, empirical formula and molecular formula. ठीक है? Vapor density. As the definition tells us, the vapor density is the ratio between the masses of equal volumes of a gas and hydrogen gas under the same conditions of temperature and pressure. See, definition anyway, if they ask, we have to write as it is. But for your understanding part, I will explain it. Okay, it is the ratio between the masses of equal volumes of any gas with the hydrogen gas. Say I have taken gas X. How much I have taken a gas X? 1 liter. Okay. Then what is its mass? Its mass is some like say 100 grams. I'm just assuming. Okay. Then you have to take the ratio of this mass to the 1 liter of hydrogen gas. What is the mass of 1 liter of hydrogen gas? To that. Say it is like 2 grams. Assume it's not exactly 2 grams. Just assume it is 2 grams. Now, how do you find the vapor density of gas X? You will do 100 divided by 2, which is equal to 50. Okay. So you have to take the equal volume of that particular gas and the hydrogen gas. Then you take the ratio of the masses of the both. You will get the vapor density of that particular gas which you wanted to find. And one formula we should know, I think we already remember, relative molecular mass is equal to 2 times vapor density, or vapor density will be relative molecular mass divided by 2. Now, relevant questions here. The vapor density of CH3OH is. Now, how do we know this? You find the molecular mass of CH3OH, methanol. You know, atomic masses, everything is given. So 12 plus hydrogen or 4 are there plus 60. So 20 plus 32. So this is what? Relative molecular mass. Vapor density will be 2 times vapor density is equal to relative molecular mass. So vapor density will be relative molecular mass divided by 2. So 32 by 2 is equal to vapor density. So 16. 16 will be the answer. Okay. Vapor density may most of the time this 1 mark question only will come. Here you can see relative molecular mass of carbon dioxide is 44. Then its vapor density is. Nisha, can you tell me the answer?
Um, it's 22.
22. That's
Yes.
it. Correct. Okay. But very rarely they have asked these kind of questions also, where they have not given you directly vapor density, but they have given you the mass of hydrogen and mass of some other gas. Therefore, you should know the definition of the vapor density. So what is this? A gas cylinder is filled with hydrogen and it holds 5 grams of the gas. Means hydrogen will be 5 gram. The same cylinder holds 85 gram of gas X. So what is the mass of gas X? 85 gram. Now same cylinder means their volume will be same now. Volume is same. Same cylinder. How much volume is the same volume will be for gas X also. Under the same temperature and pressure, calculate the vapor density. So now you have to do vapor density is equal to 85 by 5. Okay. So how much will be this? 17, 17 will be the vapor density. Okay, here definition, Gay-Lussac's law of combining volumes, one of the question paper, and vapor density also they have asked. Similar kind of question for 2 marks. Vapor density question, na very simple question. Calculation will be very simple. Gas cylinder can hold 150 gram of hydrogen under certain conditions of temperature and pressure. If an identical cylinder, same capacity, can hold 450 gram of gas G, same temperature and pressure, find vapor density, molecular weight. Aryan, tell me what is the vapor density of this?
So can you hear me?
Yeah.
Okay, so 3.
You have to show the calculation. 450 by 153.
150.
And molecular weight will be
Uh, molecular mass equal to 2 into vapor density. So 3.
6. Okay. 2 into 3, 6. Hmm.
So why are you doing vapor density 450 by 150 kg?
Because what is the vapor density? You have to take the ratio of the mass of a gas with respect with ratio of the mass of the hydrogen if they have same volume. So here
So the
gas,
formula,
that is the formula. Mass of the gas X, okay, divided by mass of the hydrogen gas. Provided both should have same volume.
okay. Sir, how do we get molecular weight?
Molecular weight is this formula we will use, no? 2 times vapor density.
Oh, okay. Fine.
Same thing. Hmm. Okay. This one again similar. Organic compound has a vapor density 22. Molecular formula of the organic compound is. How do you do this? Darshmana, tell me. It's molecular weight, not
Oh,
formula.
molecular weight.
Hmm.
So molecular weight would be 44.
Right.
So 44 is
Huh. Next, you have to find which one has the 44. Huh.
yeah.
So which one is that?
Mm,
It should be big only, no?
yeah, so D.
Hmm. 12 into 3, 36 plus 8. Right? 44. Some useful formula. Don't worry about this. I made it easy for you. Okay, na? Only this one you remember. Mole how to find. Same for gram atom, gram molecule. Remaining, don't worry. Okay. Empirical molecular formula. First of all, you should know the difference. Many of you have written a wrong answer in the previous question paper. What was asked? What is the empirical formula of ethine? They have asked. Options were C2H2 and CH. Some people written C2H2. Hmm? So empirical formula is always a formula which has a simplest ratio between the combining atoms. Okay, whereas molecular formula will give you the actual ratio between the combining atoms. For example, glucose, if you take glucose formula is C6H12O6. This is the actual formula. But if you take the simple ratio between the atoms, 6 is to 12 is to 6 है ना coefficient you see, so 1 is to 2 is to 1, then you have to do CH2O. So CH2O will be what? Empirical formula. Okay, so this is a simple thing you should know first. They will ask you what is the empirical formula of acetic acid. Acetic acid formula is what? CH3COOH. Now what you do? All the hydrogens and oxygen combine together, all the carbons. There are two carbons. H4O2. Take the simplest ratio CH2O. Okay, same thing here CH2O, CH2O. Empirical formula can be same, but molecular formulas will not be same for two different compounds. Okay. Now percentage, one question I have included here to find the percentage, just to refresh that part. Percentage composition, how to find it,
Is
huh?
that last year, right?
I don't know what is this, what years is this one. The percentage of phosphorus in the fertilizer superphosphate, they have given the formula also, correct to 1 decimal point. The percentage, how you find
We get the weight of
phosphorus?
one of that by the total weight into 100.
Yes, so total weight of phosphorus divided by total weight of
Of
compound into 100. Total weight is nothing but molecular weight only. We are talking the molecular weight. Okay. So what you have to do here? CaH2PO4 twice. It's a molecular weight you have to find. And in this, how many phosphorus are there? 2. P outside 2 is there now. So 2 times atomic mass of phosphorus is 31 divided by whatever molecular mass of this. Okay, molecular mass of CaH2PO4 2 into 100. The final answer, whatever you get, that will be the percentage correct to 1 decimal point.
224, the mass of
This one,
phosphorus.
okay. And what will be the final answer? 62 by 224, huh?
No, 234. I'm
34.
not sure it's correct though.
Okay. ठीक है then. You understood now how to do this? That is important. And second part, if you come, write the empirical formula of C8H18. This one is simple. Let's see. Rohani, tell me the answer for this. Simplest ratio to take, na? 8 is to 18.
Yeah,
Divide by 2 means what? 4 is to 9. है ना?
C4H.
Hmm. C4H9 will be the empirical formula. ठीक है. Okay, now come to this part. This is the most important. Either they will give you Gay-Lussac's law or this one. Most of the time, any one of these two will be given. So whenever they give you these kind of questions where you have to find the empirical formula, molecular formula, it is given 2 marks here, but usually 3 marks, sometimes 4 marks also it will be given. So write very neatly with all the tabular form you have to put, okay, and then write. So how you solve this? First of all, you write here element. Don't be lazy in putting the table, writing the headings, because for that also they will cut marks. Second column, percentage composition. This also will be given. Third column will be given atomic mass. First three columns will be given always the values.
The simplest ratio.
Hmm. Only two
No,
things you have to
it's
find:
yeah,
atomic ratio and
simplest ratio.
simplest ratio. These two things only you have to find. But the thing is, you don't you will not be having any calculator. So that is the thing. So here first carbon 75.92, atomic mass is 12. Then comes hydrogen 6.321, 1. Nitrogen 17.76, 14. So atomic ratio, how do we find? You take percentage composition divided by the atomic
Atomic.
mass. Okay. 6.32 by 1. 17.76 by 14. Use a calculator and tell me what are the values you're getting here. No, no, no. It will not come 7.
6.3.
Huh? 6.332.
0.32.
Okay. This is also 6.32. This one is approximately 1.026.
1.32. 1.26. To say correct.
Huh.
Yeah, 1.06.
Okay, na? Now these values don't round off. These values you keep as it is. Come to the simplest ratio. Simplest ratio, what we will do, out of the given out of the found out atomic ratios, take the smallest one and divide remaining atomic ratios by that. So here it is 6.32. Out of these three, 1.26 is the smallest, so divided by 1.26. Same thing you do here, 1.26. Here also same thing, 1.26
One
by 1.26.
five five one.
This is 1, this is 5,
Five.
this is 5. Now for simplest ratio, you have to round it off to nearest whole number. If it is coming 4.9 or 5.1, so keep it 5 only. When you cannot round it off, okay, when it is coming like 4.5, it is coming 3.5, 2.5, means zero point 0.5 it is coming, then you should not round it off. That you have to keep in mind. You have to keep it as it is, 2.5, 3.5, 4.5, whatever it is. Okay, now I will explain it later. Now see, now whatever you got the simplest ratio, that will give you the empirical formula. So write empirical formula is equal to how many carbons?
Of
5.
C5.
Hydrogens? 5. Oxygen? So
So
C5H5O.
so there's no oxygen. It's nitrogen.
Oh, sorry, nitrogen, no? C5H5N. Correct. Now see, imagine in one of the questions, simplest ratios, you got 3.5. This one has 5, this one has 1. Now what to do? You always have to take a whole number. You can't keep it as carbon 3.5. So in that case, you have to multiply all of these three simplest ratios with 2.
Two.
Okay, to make it whole number. So 3.5 into 2, 7, 5 into 2, 10, 2. This is 2. Then your empirical formula will be C7H10 N2. Okay, now. But in this case, it is not. Whenever it comes, that time you have to do like this. Okay. Now let's find out the molecular formula. Now we found the empirical formula. To find the molecular formula, we have to find the value of N. Now what is N? N is the ratio of molecular weight divided by empirical weight. Molecular weight usually will be given, or vapor density will be given. So from vapor density, you know relative molecular mass will be 2 times vapor density, that is 2.2 into 39.5. Okay, but empirical weight, how do you find? You find it from this formula. From the empirical formula, you will find empirical weight. Okay, carbon 5 are there, so 12 into 5 plus hydrogen 5 plus nitrogen 14. Okay, 60 and 90, so 79. 79 is the empirical weight. Molecular weight is what? It is also, is it 79? How much? 79 only, no?
Yes, 79.
Ha. So 2 times 39.5, if you calculate, this also comes 79 only. Hmm? So your molecular weight is 79, your empirical weight is also 79, N value will be 1. Therefore, your molecular formula. So what is molecular formula? It is N times empirical formula. Here N is equal to 1, so your empirical formula is same as molecular formula. So N is 1, so matlab C5H5N as it is. Okay, so you have to write this step by step. Actually, it will be not for 2 marks, it will be minimum 3 marks, sometimes 4 marks also. Okay, na? But if you write half of answer, then half of marks. This one question I found from your specimen. See here. Pratik heated 11.2 grams of element M with 4.8 grams of element N to form a compound. Find the empirical formula of the compound obtained by Pratik. So how do we do this? Here percentage is not given, nothing is given. But you just have to find the empirical formula. So if you are able to find the simplest ratio directly,
We have atomic mass.
huh, atomic mass is
So
given.
we can like get the ratio
Yes,
11.4.8 and atomic weight 56.
right. Okay, so you simply find the ratio of M is to N. Okay, so atomic mass is given 11.2. Sorry, mass divided by atomic mass, you do 56. Okay, is to here 4.8 by 60. So all this, how much you will get? 11.2 by 56.
0.2.
Okay, and this will be 0.3. है ना, 16 into 3. हाँ, तो you got 0.2, 0.3 matlab ratio 2 is to 3. So M2 and 3. So this is one different kind of question they have given in your specimen paper. Here no need to put the table and all. Hmm?
The formula we found is empirical formula.
Huh, this is empirical formula. You can see there is no, you can't further simplify it. No? If it is coming 4 is to 6, then you have to simplify it 2 is to 3. But it's directly simple one only. Hmm? Okay. So here this is for 3 marks. See here. Empirical formula of an organic compound C3H4N. So they have already given empirical formula. Molecular weight is also given 108. Find the amount of carbon in 1 mole of the compound. Okay. Now intermixing. First of all, you should find the molecular formula of this compound. In that, okay, you have to find the amount of carbon in 1 mole of that compound. ठीक है? So first of all, how do you find the molecular formula? N value you have to find. N value is molecular weight, which is given 108, divided by, from this find the empirical weight. 36, 4, 14, 40, 54 है ना? 54 means N is equal to 2. Now molecular formula will be what? 2 times C3H4N. Correct? C3H4N. You have to multiply the subscripts only. C6H8N2. This is your compound now. You should not find it from this. You have to take this. So in 1 mole of C6H8N2, how many moles of carbon will be there? 6, because the number is 6 now. Contains 6 moles of carbon. Hydrogen will be how many? 8 moles. Nitrogen will be 2 moles. Whatever numbers are there, those many moles will be there. Okay, now. Therefore, 1 mole of carbon is how much? 12 grams, na? Its atomic mass. 6 moles will be 12 into 6. 12 into 6. 72 grams. Okay. So whenever they give you the formula and ask you the number of any particular element in that, whatever number of coefficient, sorry, subscript is there, that will be the moles of that in 1 mole of that particular compound. Okay. Instead of carbon, they may ask you amount of hydrogen in 1 mole of this compound. So it is 8 moles. 8 moles of hydrogen atom, right? And here 2 moles of nitrogen atom. So multiply it by its atomic mass. Understood now this one? Any confusion? Okay. So here already same kind of question. Empirical formula is given, molecular weight is given. Find the N value, find the molecular formula. Okay. Here again similar. Organic compound X is there. Percentage of carbon, hydrogen are given 47 and 10.5. Here carbon, oxygen, hydrogen only. But they have not given the percentage of oxygen here. So what you have to do, find it first, then follow the same steps, whatever we did previously. Okay. So sometimes they will not give you this. They have given carbon, oxygen and hydrogen, but they have given percentage of carbon and hydrogen only. So what you have to do, find it. How you will find the percentage of oxygen? Tanisha, how you will find percentage of oxygen in this case? You have to do 100 minus whatever total percentage of carbon and hydrogen. है ना? 47.4 plus 10.5. So whatever add and minus subtracted by 100, you will get the percentage of oxygen. Okay, then you follow the same steps. That's fine. Okay, now follow the same steps. Put the table, find N value, empirical and molecular formula you can find. Sometimes they will not give you. No need, no need. Sometimes. Hmm, it's okay. It's okay. It's okay. No need, no need. And sometimes what they will give you, they will tell that an organic compound X is there, and they will tell only the percentage of oxygen and hydrogen. But it is understood that every organic compound must contain carbon. So that time you have to find the percentage of carbon and then proceed. Okay, don't do only for oxygen and hydrogen. Okay, stoichiometry questions, couple of 2 3 are there. We will take these. See here, 8.2 grams of calcium nitrate is decomposed by heating according to the equation, this one. Calculate the following: volume of nitrogen dioxide, mass of CaO formed. Okay. So what you have to do, rewrite the equation and check whether it is balanced or not. 2CaO, 4NO2 and O2. Don't use here Gay-Lussac's law. Hmm? Even though they have asked volume, they have given mass initially, 8.2 grams, right? Now from this, what you have to find? Volume of nitrogen dioxide obtained at STP. First relationship between calcium carbonate and NO2, right? So 2 moles, this coefficient you have to take, 2 moles of calcium nitrate. If you take, how many moles you are getting? 4 moles. 4 moles is nothing but 4 into 22.4 liter, correct? Now 8.2 grams means how many moles? That you find first, right? So how do you do? Mole is equal to mass divided by molecular mass. Now we have to find the molecular mass of calcium nitrate and divided by that. Okay, so calcium nitrate ka molecular formula, sorry, 40 plus nitrogen 2 will be there, correct? 28 plus oxygen 6 are there. 6 into 16 how much? 6 into 16, 96, huh?
Yes, sir, 96.
96. Okay. Okay. Now add this 96, 124, 164. Correct, huh?
Yes, sir.
164. So this will be how much pa?
0.2, I think.
1 by 2, na? Point 1 by 2.
Oh, shit. 1 second.
Correct, huh? Point 1 by 2.
Yes, sir. So it will be 0.05.
Hmm. Please check all of you whether 8.2 by 164 is 0.05. Most of them, I think they have slept, it seems, huh?
Yes, sir. 0.05 only.
Okay. Now you know 2 moles of calcium nitrate will give you 4 into 22.4 liter of NO2 at STP. Therefore, 0.05 moles will give you how much? So cross multiplication, same thing. 4 into 22.4 into 0.05 divided by 2. Okay, 2 and 2 cancels, and remaining you add, sorry, multiply 2 into 22.4 into 0.05. How much you are getting? Tell me. 2.24
2.2.
liters. This will be the NO2 gas. So you have to take the moles to mole ratio. Okay. Then connect it with it with the volume. 1 mole is 22.4 liters. So therefore this one. Mass of CaO formed. When you are taking 8.2 grams, what will be the mass of CaO formed? Again, same thing you have to do. 2 moles of calcium nitrate will give you 2 moles of CaO. Means the ratio between this will be 1 is to 1. है ना? So B part. So 1 mole will give you 1 mole. Therefore 0.05 mole will give you 0.05 mole of CaO. Now find the mass of CaO multiplied by 0.05. Calcium is 40 plus 16, 56. 0.05 into 56. 0.05 into 56. 2 point
So 2.8.
grams. Grams you have to write. Unit if you don't write, all the calculation you do wrong only. No marks. Okay. So here mole to mole, then it will be easy, but you can also take mass to mass also. But that time you should not miss the coefficient. Therefore, I am telling you take mole to mole, then connect it with the other masses or the volumes. Same question, no? Repeated. Here it is asked 4 marks. Okay, the it is given in specimen. Same
So I go
question.
take some water.
Yeah, yeah. Okay, only two questions are there. Okay, after that we will leave. This one question you see, decomposition of ammonium dichromate. N2, Cr2O3. When it comes in your greenwood paper, first check whether it is balanced or not. Okay. Hmm. So what they have here asked here, if 126 gram of ammonium dichromate decomposes, calculate the number of moles of ammonium dichromate that undergoes decomposition. That's very simple. है ना? So first you find the molecular mass of ammonium dichromate. That is a little big task. Can anybody check what is the molecular mass? Google it. Molecular mass of ammonium dichromate.
252.07.
We'll keep it 252. Okay. Molecular mass of ammonium dichromate is 252. Therefore, they have asked the number of moles of ammonium dichromate, that is 126. So, moles will be 126 divided by 252. I think it should be double, no? 1 by 2.
Yeah.
0.5 moles. That is the first thing. Second one, the mass of chromic oxide formed at the same time. So chromic oxide is Cr2O3. Same time matlab when you take 0.5 moles of ammonium dichromate. Now you know the ratio. 1 mole, coefficient of ammonium dichromate is 1. Chromic oxide is also 1. So the ratio between them is 1 is to 1. Right? So B part, 1 mole of ammonium dichromate gives you 1 mole of chromic oxide. Therefore, 0.5 moles will give you 0.5 moles of chromic oxide.
Moles.
So what they have asked here, mass. So find the molecular mass and multiply it by 0.5. Chromium ka atomic mass is 52 into 2, 104 plus 48. 152, correct? So 0.5 into 152. Okay. So 76 grams. Is